Okay, so the whole purpose of this is that we may be able to make this much easier on ourselves if we could just get rid of the fractions, because having fractions to deal with, it stinks, it's hard to work with. It'd be easier if we didn't have the fractions. So what we're going to do is try to get rid of the fractions. So this one has a t in the denominator, and this one has a t plus 7 in the denominator. This one has a 1 in the denominator. So there's like 3 separate things going on. But I don't really care about the 1, because if I multiply something by 1, it's not going to change. All right, let's do one thing from the beginning just to save ourselves the work. What things can t not be? Like, what numbers can t not be?
-7.
Okay, t cannot be -7 because t plus 7 equals 0. If you were to subtract 7 from both sides, t cannot equal -7. What's the other thing t can't be? It just can't be 0. So here, t can't equal 0. Here, t can't equal -7. Or it would be undefined. So I'm identifying those now because if either one of those pop up as answers, we need to remember that those two are on restriction. We're not allowed to use those. Those would not be good answers. So they may pop up, they might not. But I would rather just know from the beginning what things I'm allowed to use and what things I'm not. So I'm going to multiply by something. And whatever those, or some things rather, to make these go away. What do I need to multiply to make these things go away?
T open parentheses t plus 7.
So I need a t. I definitely need to multiply by t. And I also need to multiply by a t plus 7. Because this one over here needs a t plus 7. It doesn't have a t plus 7. And this one over here doesn't have just a t. It has a t plus 7. It doesn't have just t by itself, though. So we're going to multiply the first thing by t and t plus 7. We are going to multiply the second thing by t and t plus 7. Is equal to, and then we've got that 1 over 1 will be multiplied by t and t plus 7. But here's where it all kind of works out kind of nice, because what is going to cancel out? Let's talk about the first one. What cancels out here? Yeah, that t is going to cancel with this t, leaving just 12 times t plus 7. We'll work that out in just a moment. We're going to go on to the next one. Here, what cancels out? The t plus 7, leaving just 12 times t. And what cancels out on the last one? Nothing. So now it looks much easier. There's no more fractions, so we're going to deal with this now. What's the first thing that I should do? Yeah, let's distribute here. And we get 12t, and what's 7 times 12? 84. Plus 12t, there's nothing to be done there, is equal to, now this t needs to be distributed as well. What do we get over here? T squared plus 7t. Now usually like people can get here, but what do I do now? Okay, what do we want to subtract? Okay, here we can do that. Here's the only reason why I would recommend doing the other is that I know that we like to move things to the left, and I'm not against that. It'll still work just the same. But see how the one that has the highest power is a t squared? Like, it's already a positive number. If I move it to the other side, it's going to become negative, which is going to make it really hard to factor. So just for this one, I'm always looking at that highest power there and going, I kind of want that leading coefficient to be positive. So let's move everything to the right after we combine anything that can be combined. Is there anything that can be combined?
Yeah.
Which can be combined?
12.
And? Which becomes?
24.
Okay, so we get 24t plus 84 is equal to t squared plus 7t. Now, just so we can keep that t squared positive, let's move everything over to the right. So what can I move? Okay, let's subtract 24t and 20, oh, that's not a 4. 24t, yes ma'am?
Couldn't you like subtract the 17 from the 24?
You could, but then you're moving everything to the left. And we can do that, like, but your t squared is going to end up negative then, and then we're going to have an extra step where we have to turn that t squared positive.
By dividing it by negative?
Yeah, which is okay, and that's okay. There's nothing wrong with that. I like to avoid those negatives whenever I can,
We did that yesterday, but I divided by negative.
and that's okay. You can divide by -1. It'll fix that problem. So what is 7 minus 24?
17.
-17.
Can you please set Bianca Winston down to student services?
She's on her way,
Subtract 84.
and we'll subtract 84. Okay, so we've got t squared minus 17t. Let me just clean this up. We've got 0 is equal to t squared minus 17t minus 84. Now, what should I do with this? Let's factor it. Even if we're not sure what two things, 84 is not a common number that we deal with, but I'm sure that we could figure it out.
I got t minus 21
Okay,
and t plus 4.
let's just check those real quick. T minus 21 and t plus 4. 21 times 4, negative 21 times positive 4 is definitely negative 84. And negative 21 plus positive 4 is definitely negative 17. So this one checks out. What's next?
You equal both of them to 0.
Set each one equal to 0. T minus 21 is equal to 0. T plus 4 is equal to 0. In this case, t is equal to 21. T is equal to negative 4. Were either of those numbers on restriction?
No.
No, so these are both okay. I think the numbers that we said we couldn't use were -7 and 0. That's not one of the possible answers, so we don't need to worry about them. T can be 21 and t can be -4. That will work for this problem right here. I'm going to zoom out so everyone can see. Okay, and our last one down here. So this one's a little bit easier to deal with. When it comes to the denominators, I'm definitely going to need to multiply by an r. That's something I need to get rid of because I need an r to get rid of them. But what number could I multiply by that will get rid of both a 3 and a 9? 9, right? Because 9 is the smallest number that both 3 and 9 go into. So what I'm going to multiply everything by is a 9 and an r, 9r. Because the 9 will get rid of the 3, the 9 will get rid of the 9. The r will get rid of the r. So it gets rid of all the denominators. So first thing we're going to do is multiply the first thing by 9r. So there's 9r times 5 over 3 plus 9r times 1,000 over r is equal to 9r times 25 over 9. Yes, sir.
It still wouldn't be wrong if you do times 3 times r times 9 to the whole thing, right?
3 times r times 9.
Yeah.
Your numbers are going to end up much bigger than everyone else's because if you do 3 and 9, then what you're multiplying by is 27. So you're right, it'll get rid of everything, but your numbers are going to be much bigger, which means you're going to have to do more division at the end. It'll still work out as long as your numbers are as long as you do all your math correctly, it'll still work out. But you don't want to go too much bigger because if you do, the numbers get huge and it gets kind of bad. So 3 goes into 3 once, 3 goes into 9 3 times, leaving 3r times 5 for the first one. Plus, this r is going to cancel out with this r, and 9 times 1,000, I think I can do that in my head, that's 9,000, is equal to 9 cancels out with 9, leaving just 25r. All right, so we've got 3r times 5, which is 15r, plus 9,000 is equal to 25r. All right, what do we want to do next?
Subtract 25.
Okay, we can subtract 25r. Our r's are going to end up negative. It's fine. We can do that, and then we're going to have to move the 9,000. Here's why I would rather move the 15r. We only have to move one thing then. You see what I mean? If we move this, then our r's are going to be on one side, and our numbers are going to be on the other. So a lot of people like their variables on the left or something. Sometimes you have to evaluate which is going to work out better for you. I'm going to move the 25r because that's what you recommended and there's nothing wrong with it. I just want to show you that it's going to take, we're going to have a couple extra steps, which is totally okay. So, yeah,
Let's say you move the 25r.
that's what we're doing.
I know, but can't you just switch it back by adding it again?
Yeah, you can always go back if you don't like what's going on. You can do it. So 15r minus 25r would be negative 10r plus 9,000 is equal to 0. So now we got to move the 9,000 over to the other side then. So we get negative 10r is equal to negative 9,000 because we subtracted 9,000 from both sides. Okay, so we're looking for r, so we got to divide by negative 10, and we got to divide by negative 10. So this becomes r. What does this become over here? 900, a positive 900, because a negative divided by a negative is a positive, and one of these zeros will cancel out with one of those zeros, leaving just 900. So I'm going to look real quick up top to see whether that's an issue, like is 900 going to be a problem? So looking back at the original, is 900 an issue? No. The only number that's going to be an issue is what can r not equal? 0. That's the only number that r can't equal. It can't be 0. Yes, ma'am?
You have to write what it can't equal.
It didn't ask it on this one, but let's say it did. If it said, like, identify where it is undefined, well, then we would want r cannot, you could add just that on to the answer, r cannot equal 0.
And we would also.
I wouldn't mark you off if you added that on there. So, like, just to be safe, you could add it on there. Like, there's nothing wrong with that. This is really what we're looking for on here because it just asked us to solve. But if it said solve and then identify where it is undefined, then we would need this as well.